Great, so welcome back, and this is a question called balanced binary tree, and it's an easy level binary tree question where we are given a tree and we want to check if its height is balanced. So the important thing to realize that a balanced binary tree is not only balanced at the root level, but the subtrees are balanced for every node. So, I crossed it out. So every node should differ in height by no more than 1. And so at least at the simplest case at the root level, we want to make sure that its subtrees here and here have a difference in height no greater than 1. And so this has a height of 2, this one has a height of 1, and so that works because 2 minus 1 is 1. But then we also want to consider, okay, at this node's level, are its subtrees also balanced? Well, this one has a height of 1, this one has a height of 1, so which the difference is 0, so they're okay. That one is also balanced. But in this case, we look at, okay, are these subtrees balanced? Yes, they are. We look at, okay, is this subtree and this subtree balanced? It is, because this has a height of 2 and this one has a height of 1. And 2 minus 1 is 1, which isn't greater than 1. And then finally, we see that, okay, the height for these two subtrees is greater than 1. So if we counted the root level, its height is 4, and then this one's height is 2, and 4 minus 2 is 2, which is greater than 1. So we know that we want to return false because it is in balance. So just make sure that you're not just looking at the difference in height of the subtrees kind of at the root level, but we're considering every single node here. Difference in height here, difference in height here, and then finally the difference in height here. Okay, so to do this, what we're going to do is, let's just get started, is we're first going to check if the root is null, and if so, we just want to return true. So in the simplest case, if we just pass nothing at all, we would just return true. A null tree is true. But in the more kind of complicated or more often scenario, what we're going to be doing is we'd say, okay, when we hit these leaves and go further, and we want to compare the height of its subtrees, its null subtrees, we just want to return true, because when we're just checking for all the tree that all the subtrees are true and all are balanced, and we want to return true, we don't return false in this case, because that could mess things up. And I hope that my explanation makes sense there. So because we're constantly checking is false, or is true, we don't return false on these kind of leaf nodes here. And so next, what we're going to do is, otherwise, we're going to check the max height of its subtrees. So we're going to go both left and right, and we're going to call a method that we're going to make, and it's going to be called, let's just say, get max subtree height. So long method name, but I hope that kind of helps clarify what we're doing with it. So we're going to call root.left and then root.right. So this is going to be used so that we can then compare the difference between the left and right subtrees heights. Okay, so let's go ahead and just implement this before we go any further. So this will be a private method, since we're just calling it from our public method. And it's going to return an integer, which represents the max subtree height. And we're going to pass a tree node, and we're just going to call it node. And so once again, we're going to check if the node is null. We just want to return 0, because, well, the height of a null tree is 0. And so otherwise, we want to return 1 plus, and I'll explain this in a second, the max subtree height of the left side compared with the max subtree's height of the right side. and we're going to get the maximum of these two recursive calls. So I'm just going to expand this so you get a better look at it. So what we're doing here is we're adding 1 for every single kind of layer, and then we're getting the max difference or the maximum height of its left and right subtrees. So what this looks like is, because the root is not null, we add 1 here, and then we go down a level and we say, okay, we go left and right, and since these nodes are not null, we add 1 here, and then we go down a level and we see its left and right children are null, so they just both return 0. And at this level, or at this node, we go left and right. They both aren't null, so we add 1. And then we go left and right on its children, and we see, okay, they're both null, so we return 0. And then as we merge those results together, we then see, okay, the maximum of its children is 0, so 1 plus 0 is then, we can head up here, we add 1. The maximum of its children, right, because we're getting the math.max, is 0, so 1 plus 0 is then 1. And so then at this level, we look at, okay, what's the max of its children? The children of the number 20 here, or node with a value of 20. Well, its max child is 1, so we do 1 plus 1, which we then send up 2. And then here we look at its children. Its max child is 0, so 1 plus 0, we send up 1. So now at the root level, we then look at its children, and we see, okay, the kind of max subtree height is 2 here in this case, because 2 is greater than 1. So we do 1 plus 2, and that is equal to 3. And so we would expect, at least at the root level, we would return 3 in this case. Okay, but if this method was called lower on, so if we called this method at this node, we would say, okay, it's 1 plus the maximum of its children. Well, this one is 1, and this one is 1, and their children are zeros. Oh, those are terrible zeros. Their children are zeros. And so 1 plus 0 and 1 plus 0, these both return 1. And so in this case, 1 plus 1 is equal to 2. So for this node, we would say that the max subtree height is 2. Okay, so now what we're going to do is we're going to check that the difference of these two subtrees is no greater than 1. And so we say, okay, math.absolute, left minus right. And we're doing the absolute because we don't want to worry about negative cases. And so if the height is 0 or 1, then we know it's balanced, otherwise it's false. And then what we're going to do is we're going to recurse on this method going left and right. And I'll just quickly run this, see if we have any errors. Oh, looks good. Great, so the reason why we're doing this is because we want to check the max subtree height at every node, not just at the root level, but for every node beyond that point. So it's checking this case where we don't want to just check, okay, is the height difference at this level balanced? You know, this is 2 and this is 1, but we want to check it at lower levels, like at this node. Is its subtrees balanced, where this one has a height of 2 if we count the root node as 1, and this one has a height of 2? Well, it's balanced. So we don't want to just care about at the root level. We want to care about every single node. So make sure that the left and right subtrees of every node differ in height by no more than 1. Okay, so I hope I really narrowed down the point there. That's the part that confused me, so I'm sorry if I keep repeating it. But yeah, I hope my explanation helped, and good luck with the rest of your algorithms. Thanks for watching.